Our final portion of our lesson 6.2 on the binomial probability distribution will be a series of examples that will cover things similar to what you will find in your homework, quizzes, and tests, and give you an opportunity to practice doing some of the problems using your calculator. For this portion of the assignment, please make sure that you have your calculator ready so that you can practice some of the commands as we go along with the lesson. This slide demonstrates the instructions for how to get the binomial probability distribution calculations on the calculator. As you can see, there are two sets of directions. The first one will get you a binomial PDF distribution, and the second one will get you a binomial CDF distribution. Now, just to make sure we understand the difference between the two, the PDF distribution is used if you are trying to find a precise probability. For example, if you want to know the exact probability of getting 7 successes out of 10. The binomial CDF distribution is used if you want a range. For example, you want to know the probability of getting 7 to 10 successes, or less than 8, or more than 5, etc. For the first series of examples, we're going to be looking at the same situation where the probability of success would be, suppose 70% of all Americans have cable TV, and we're going to be looking in a random sample of 15 households every time. Now, the first question asks us to construct a binomial probability distribution. Now, remember back in section 6.1 that the probability distribution means you want the table of all possible probabilities. And it's very simple to do on the calculator. With the commands on the previous slide, you can see we're going to generate this command here. All right, so you're going to be generating a probability distribution. And as you'll notice by the command on my calculator, you see there's these two arrows on the side, which means that you're able to scroll through. And so I want you to take a second to do this on your calculator. So you're going to end up pausing the video to practice, and then you'll push play again to check your work. Now, how it will work is you'll do the binomial PDF command, and you'll put 15 in for the number of trials, and you'll put 0.7 in for the probability, but you'll put nothing in for the value of the probability you're trying to find, because you don't want 1, you don't want 2, you want just all of them. So give yourself a second to try to do this, hit pause, see if you can come up with the answers, hit play, and they'll be here for you. Now here you can see the answers for the probabilities of all 16 possible scenarios, which again was gotten from this list here, scrolling through left and right, starting the very first number listed would be 0, and then scrolling all the way through these numbers using the arrows, you'll eventually get all the probabilities for every single possible situation. So now you have a table you could look, what's the probability of 5? It would be 0.002 or 0.298%. One thing I want to bring your attention to is this number up here. All right, this is scientific notation on your calculator. So the 0.1434e -8, that means move the decimal point to the 8 places to the left, which if you did that, you would have so many zeros. It's pretty much the probability of 0. Now, it's not exactly 0, but for the most part here, just to shorten it up, we can put 0 there. And you can see these probabilities here would be extremely low, because the chances of getting 2 or 3 TVs with cable is pretty low when 70% of the Americans have it. Now, the next set of examples, we're still going to be dealing with 70% of all Americans having cable TV, and we're going to randomly select 15 households. But in these examples, we're going to look at various possible probabilities. Now, in this one, it says, what is the probability that exactly 10 households have cable? Now, because we're using that term exactly, we're going to use the binomial PDF. Remember, PDF is used when exactly is part of the question. So in the calculator, we would go to our binomial PDF, the menu 55D. You're going to input 15 for N, 0.7 for P and 10 for X, and then hit enter. And pause the video, go through the calculation on your calculator, and then hit play again to see if you got the answer correct. So the answer you should have gotten was 0.20613. So therefore, there is a 20.6% chance of choosing randomly 10 households out of 15 that would have cable TV in an experiment. Now in this example, we're working in the same scenario, but the question's worded slightly differently. So it says, in a random sample of 15 households, what is the probability that at least 13 have cable? So that means the least amount that we want to calculate would be, or have, would be 13, which would consider 13 is a success, 14 is a success, and 15 is a success. So if all three of those situations are successes, we essentially need to add up all three possibilities. But if we use the calculator, we can actually get this situation all at once and just input the command. And so we want the probability that X is greater than or equal to 13, meaning 13, 14, 15. We're stopping at 15 because remember our sample is only 15. So we don't want to go above 15 because we're only sampling 15 and that wouldn't work. And so we want to do our binomial CDF this time. Remember CDF because we're doing a range. All right, and so we're going to go to the command. All right, we're going to input 15 for our N. Our probability of success is 0.7, and then we want to input our low and our high. So our low that we want to input is 13, and the highest is 15 because you can't go over your N to begin with. And so I'm going to give you a chance to input that into your calculator, pause this video, and then hit play to see if you got the answer correct. And so the answer you should have gotten in your calculator was 0.1268, which means there's a 12.68% chance that at least 13 houses in your sample will have cable TV. Now, one thing before we go on to the next example that I want to make sure that you are aware of for when you're doing your homework, your quizzes, and your tests is that I want to see this command written down on your homework paper, quiz paper, test paper. I want to know what was inputted into the calculator along with the answer that you got. So then if you're getting the wrong answer, I might be able to see maybe where you're making your mistake in your input and get partial credit or give you feedback on your homework to let you know where you're making your mistakes. So remember, this input here will show up on your calculator screen after you hit enter, and so you'll be able to see that and the answer. So just make sure that it's written on your paper as well. All right, continuing with the same example, we have a random sample of 15 households. What is the probability that fewer than 13 have cable? Now notice the way the problem is written, we want the probability that X is less than or equal to 12 because fewer than 13 does not include 13. It means anything below 13. So 12 would be the next possibility because you can't have like 12.5 houses. It's 12 and then 13. So notice 12, not 13. So we want to go ahead and input this into our calculator using the binomial CDF command. All right, so I would like you to pause the video, input these into the calculator, and see if you have the right answer. Now, notice the way that this is written. We have 15 trials, we have a success of 0.7, and our low is 0. This is important because it doesn't tell you that the low is 0. But remember, in binomial probability, you can't go below 0. So 0 has to be your boundary, and then your high number is 12. So if you happen to have chosen not 0 or not 12, then you may want to re-put this into your calculator, pause the video, and then see if you get the correct answer. So after you hit record, then you should end up getting the correct answer of 0.8732, which makes it a 87.3% chance that fewer than 13 houses will have cable. Now moving on to the next example, we have, according to flightstats.com, American Airlines Flight 1247 from Orlando to Los Angeles is on time 65% of the time, And suppose 15 flights are randomly selected and the number of on-time flights is recorded. And then we have various questions to answer about that situation. Now, before we start the example, just note that this is your P, your probability of success, and then your 15, that's your number of trials. And that's your N value up here. So right here would represent the N. Now the first part of the question says, explain why this is a binomial experiment. So this goes way back to the very first part of the lesson where we had to talk about the characteristics. So one of the things that always has to be true is there are two options. And in this case, the two options are either the flight is on time or the flight is not on time. Easy as that. Each one is independent. That was one of the other characteristics. They had to be independent. The one flight does not affect another flight. They're completely independent. And then the other requirement is that they're mutually exclusive. Meaning that they don't have any relationship to one another. The probability stays the same every time. It's always 65% no matter what. The next part says find the probability that exactly 10 flights are on time. So that means we want binomial PDF, because remember PDF is for exactly. There are 15 trials. All right, the probability of success is 0.65. And we want exactly 10. And so we're going to take that information, you're going to pause the video, put it into your calculator, and see if you got the right answer. And when you're ready, hit play to check your work. Now the correct answer is 0.2123, which is 21.2% chance of 10 out of 15 exactly. Now, the next one says, find the probability that at least 10 flights are on time. At least 10. All right, so now that would be 10 or more. So now we're moving on to the binomial CDF because we're doing a range. There's 15 trials. Our probability is 0.65. All right, 10 is the least it can be, and 15 is the most because you can't go over the number of trials. That doesn't make sense. All right, so input that into your calculator, pause the video, and see how you did. So the correct answer here is 0.5643, and so there is a 56% chance that at least 10 of the 15 flights will be on time. Part 3, find the probability that fewer than 10 flights are on time. So now this is binomial CDF again, because we're doing a range. We have 15 trials, 0.65 is our probability, and fewer than 10 would mean 0 to 9. Remember, you can't go below 0, because 0 is the lowest number. Can't have negative flights, and you can't go above 9, because fewer than 10, the next possible thing would be 9. You can't have decimals. So input that in your calculator, pause the video while you work, and then hit play to check and see if you are correct. Now the correct answer is 0.4357. All right, and the final, find the probability that between 7 and 10 flights inclusive are on time. Now this is still a range, so we're doing binomial CDF again. 15 trials, 0.65. And between 7 and 10. Now, inclusive means include those numbers. So our low is 7 and our high is 10. And then put it into your calculator, pause the video, and then when you're ready to check, push play. And the correct answer is 0.6059. So that's a 60.59% chance that between 7 and 10 flights are on time out of 15. Now our final example says, according to the Uniform Crime Report 2006, nationwide, 61% of murders committed in 2006 were cleared by arrest or exceptional means. For 250 randomly selected murders committed in 2006, compute the mean and the standard deviation of the random variable x, the number of murders cleared by arrest or exceptional means. So going back to the second part of the video, remember the mean, mu of x, is equal to n times P. So N, which are 250, and then P, which is the probability, would be 0.61. So just following the formula, we input that into our calculator, type it in, pause the video, push play to check if you're correct, and you should get 152.5. Next up says the standard deviation. So remember, the standard deviation is equal to the square root of N times P times 1 minus P. And you can input that into the calculator by using the square root button, and you can just type it in exactly like it looks and then hit enter, and that should give you the answer. So pause the video and push play when you're ready. So the correct answer should come out to 7.712. Now the next part says interpret the mean. So what does this actually stand for? So remember back from section 6.1 that the mean represents the expected value. So we would say the expected number of murders cleared by arrest or exceptional means out of, you always got to say out of 250 because it makes a difference out of how many you're looking at, would be 152.5. So that means if we were to take 250 random cases, we would expect to get about 152 or so of them that were cleared by arrest or exceptional means. Now, remember, that doesn't guarantee that's what you'll get. That's just the average, or what maybe you would expect to happen, but that doesn't guarantee it will happen. And finally, the third part of the 250 randomly selected murders, find the interval that would be considered unusual for the number of murders that was cleared. So remember, unusual, all right, the key to unusual is 2 standard deviations. Because remember back from the empirical rule, anything outside of 2 standard deviations, which is 95%, would be considered unusual. So what we got to do is we got to figure out where that range would be. So if you have your mean, which is 152.5, we want to go 2 standard deviations in both directions. And that will tell us the boundaries. So remember, the standard deviation is 7.712. So if we basically add 7.712 and then add 7.712 again, that's going to give us 167.93. And then we want to subtract 7.712 and then subtract 7.712 again, going the other direction, and then that will give us 137.076 approximately. So the boundaries for unusual would be between 137.076 and 167.93. So to answer your question, the find the interval that would be considered unusual, you would say below 137.07 or above 167.93. So that would answer your question. So the unusual would be on the outer edges. The usual then would be in the middle. So 2 standard deviations essentially is your boundary for usual into unusual. So remember, it doesn't mean that if you selected 250 cases that you couldn't get below 137. It just would be unusual for that to happen, not impossible.